Thank you, Kathy. Oh, so, okay. There we go. I'll move beyond that. Throughout the 1960s and until the end of the Apollo program in 1972, the focus of NASA's human spaceflight initiatives spent little time on what it meant to live in space. After John F. Kennedy's announcement in May of 1961 that we would go to the moon and back, NASA's engineers went to work designing new technologies that would keep astronauts alive for the short duration of their missions. Given the relatively short time frame that NASA had to accomplish Kennedy's goal, concern about the astronauts' comfort and quality of life in the process of innovation simply had to be relegated to the back burner. On July 21st of this past summer, Space Shuttle Atlantis landed for the last time, bringing an end to the shuttle program's 30 years of service to NASA, its contractors, and patrons. This long-term program, as well as the International Space Station, which has been continuously occupied since November 2000, has contributed the most extensive data on living and working in space. NASA's studies on the impact of the low Earth orbit environment on the human body began in earnest in the early 1970s with the launch of Skylab, which you see on the upper right-hand corner of this slide. This was America's very first space station. These three programs, Skylab, Shuttle, and ISS, along with what has been learned aboard the Russian space station Mir, which you see in the bottom right-hand corner, have shaped not only our understanding of what humans experience when living and working in space, but also provide some insight into what hurdles still exist into deeper human exploration of the solar system. This talk will examine the solutions to some of those challenges faced by NASA's human factors engineers in designing Skylab, the shuttle fleet, and the International Space Station. In addition, it will consider the larger social consequences of living and working in space, particularly as they relate to sex and gender. In 1964, Frank V. Horace, the NASA Chief of Human Research, wrote a pamphlet for public distribution about the hazards and safety concerns for astronauts. With limited human spaceflight experience to that point, and I will point out that when he wrote that pamphlet, the longest mission that had been undertaken by an American astronaut was undertaken by Gordon Cooper. It was 22 orbits long and lasted for only 34 hours. The concerns that Voorhees and his colleagues cultivated about astronaut health stemmed largely from a real lack of data. His greatest concerns involved the long-term effects of weightlessness on the body's cardiovascular and skeletal systems, radiation exposure, metabolism changes, how to handle bodily waste, and to a lesser extent, psychological problems. While most of these concerns were inconsequential for the short-term flights being flown in the 1960s, as NASA turned its focus towards longer duration flight, these issues of astronaut health and well-being became much more significant. In this talk, I want to focus on three particular elements: eating, sleeping, and waste containment. That's the fun part. In the early 1970s, NASA engineers had started designing the interior components for the new space shuttle. Knowing that flights would regularly last for 7 to 10 days and for up to 2 weeks in length, and that the shuttle would regularly carry 5 to 7 astronauts, a significantly larger complement than any other vehicle NASA had previously designed, making sure that the astronauts were able to live and work comfortably in their environment took on new meaning. In addition, for the first time in NASA history, men and women would fly on board together, meaning that engineers had to design the shuttle's components to work with both male and female anatomies and incorporate some elements of privacy, something that was very much lacking in the Gemini and Apollo capsules that you see here. Simultaneously, engineers at Marshall Space Flight Center in Huntsville, Alabama, were running point on the design and construction of Skylab, a project that developed out of the Apollo Applications Program begun in 1965 to define NASA's mission after landing on the moon. Skylab became a bona fide orbiting workshop and laboratory for extended research in low Earth orbit. For a total of almost 172 days between May of 1973 and February of 1974, 3 crews of 3 men lived aboard Skylab and conducted solar and Earth observations, along with an extensive battery of life science experiments. Many of the medical experiments that researchers at the Manned Spacecraft Center in Houston designed for these missions attempted to address the concerns that Dr. Voorhees had emphasized back in 1964. The driving question behind the life science experiments during Skylab was, how do we keep our astronauts happy and healthy in space and make sure that they are healthy when they return to Earth? Part of keeping astronauts happy and healthy involved providing a sense of normalcy, done so through familiarity and routine. We all understand the concept of comfort foods. These are very often our personal favorites that fill us with nostalgic feelings of the past or connect us with positive emotions. But in a microgravity environment, some of the foods simply aren't an option. In space, everything floats. And that's certainly an example of everything. In this particular image from the Space Shuttle era, we can see mission specialist John Lounge playing with his food. That's fruit punch right there in the middle. It goes without saying that foods such as fruit punch and other things like gravy and crumbly items do not mix well with computers and high-tech equipment. In addition, fresh fruit and products with a high water content are heavy, which is always a major concern in the design of vehicles and launch systems. During the Mercury and Gemini programs, food packets were designed with 3 things in mind. It had to be packaged so it took up minimal space, it needed to survive launch and not spoil, and it had to provide balanced nutrition for the astronauts. What resulted was a product that was far from enjoyable. Little changed for the Apollo astronauts, but those astronauts actually began complaining more and more about palatability of the food that was being offered. Consequently, the nutritionists working on Skylab and the shuttle worked on trying to improve the eating experience. Part of the problem with food in the 1960s was that homogeneous food, like vegetable purees and pudding, which both could be packaged in a squeezable tube very easily, along with bite-sized solids that actually had a wax coating to cut down on the number of crumbs. Those were the easiest way to ensure nutritional consistency. But heterogeneous foods, things like spaghetti with meatballs and chunky stews, which are the foods that offer the textures that more people prefer, made it more difficult for nutritionists and physicians to guarantee that the astronauts were meeting their daily dietary requirements, particularly for Skylab and ISS, of which the missions would last for weeks or months. The greater concern was that the issues of palatability would ultimately result in the astronauts not eating at all. By 1969, the concept of habitability overruled medical requirements, at least with regard to food. So better food and a greater variety of options made most sense. So what you can actually see here is a training mission for Skylab 2 where the dining experience really does become familiar. It's set around a table. The foods are laid out in front of them, and they're enjoying very much a family-style meal. And in fact, as Dr. Voorhees noted back in 1964, a good Sunday dinner, so to speak, will keep the astronaut in touch with reality. So part of the experience that you see here is about that process of normalcy and creating a familial and family and comfortable environment for the astronauts as a way of keeping them grounded. Beginning with Skylab and continuing through the shuttle and ISS, NASA employed nutritionists and chefs to develop foods that could be dehydrated and rehydrated without negatively affecting consistency, and packaging foods that would not require refrigeration or special handling. By the launch of the first Space Shuttle Columbia in April 1981, about half of the foods and beverages were dehydrated. A NASA fact sheet published in January of 1983 about life on board the shuttle identified a variety of foods available to shuttle astronauts, including sweet rolls and sausages for breakfast, ham and cheese sandwiches, bananas and cookies for lunch, and shrimp cocktail, beefsteak, broccoli au gratin, and pudding for dessert or for dinner. For ISS missions, which typically last 2 to 6 months with resupply missions every 2 months, even greater variety is available, including such foods as Russian cottage cheese with nuts, spicy lamb stew, pasta, fried rice, duck cassoulet, and beef with burgundy sauce. In addition, astronauts can now combat the blandness of Apollo-era foods with condiments, such as the typical mayo and mustard that you get in the squeeze packs, and some more adventurous additives like Thai chili sauce and garlic paste. The astronauts can also use salt and pepper, but unlike how we think of it here on Earth, salt and pepper come in liquid form because you cannot sprinkle it on your food. You simply have to squeeze a drop of the liquid in and mix it in on your own. Another daily function that on Earth at least is particularly affected by gravity is sleeping. You see an image here of Alan Bean in his sleep compartment aboard Skylab 3, and he's reading right now, but he is in fact bedding down for the night. To relax enough to drift off to sleep on Earth, ideally we lay down in a bed, rest our heads on a pillow, and cover up for warmth and a sense of security. In space, the problem isn't so much about relaxing and drifting off to sleep, but rather drifting into something important after you've fallen asleep. Aboard Skylab, astronauts slept in these individual sleep compartments. And I do want to point out, make note of what he's wearing or not wearing, because that will in fact become important later. These sleep compartments served two purposes. One, they kept the astronauts secure while they slept, and more importantly, these sleep compartments provided astronauts with privacy, one of the more important elements of habitability that concerned the human factors engineers when they began designing Skylab and the shuttle. Compared to Skylab, the shuttle's flight deck and middeck measured about 1/4 the size. It's 71.5 cubic meters compared to 270.2 cubic meters in Skylab's orbital workshop. In addition to being 1/4 the size, it's carrying twice the number of crew. Of course, compared to the Apollo spacecraft, which had only 10.4 cubic meters of space, the shuttle was relatively comfortable. But with a crew of 5 to 7 people, space was a commodity to be managed carefully. More so with the shuttle than with Skylab, the human factors engineers made habitability and particularly privacy a top priority. Like with Skylab, shuttle astronauts experimented with sleep bunks. This is actually an example from STS-35 where you can see 3 sleep bunks and a few of the astronauts enjoying those bunks. The astronauts aboard Columbia on this particular flight utilized a practice known as hot bunking, in which 2 or more astronauts working in different work rotations would share the same bunk. And this is something that you see on seagoing vessels in the Navy all the time. The shuttle's middeck was fitted with 3 to 4 of these individual sleeping berths. In an interview with astronaut Kathy Sullivan, she noted that with such a large crew, having these bunks on board cut into already limited space on the middeck. But when the mission called for 2 separate work shifts, having a private and quiet place to get some sleep seemed more important than actual physical space. Sometimes, however, what the engineers deemed as a priority habitability issue was different than how the astronauts actually felt. Sullivan noted further that the astronaut corps would ultimately scrap the privacy of these hot bunks for a little more elbow room. With the hot bunks removed, the solution were these sleep bags that are basically strapped to the wall of the middeck. One of the driving forces behind the engineers' focus on privacy is a habitability issue, as a habitability issue, was the fact that with the introduction of the space shuttle, you have a new kind of astronaut, which you can see in this slide. It is the female astronaut. This is actually an image of Anna Fisher on STS-51A, which is her first flight. In 1978, when NASA introduced its Group 8 astronauts, 6 women were part of this new class of 35. They were Anna Fisher, who you see here, Shannon Lucid, Judy Resnick, Sally Ride, Ray Seddon, and Kathy Sullivan. Having women and men flying together raised concerns about sexual propriety and privacy aboard the shuttle. One concern that arose was sleepwear. If you remember, as I said, remember how Alan Bean was dressed for bed aboard Skylab, you will remember he was not wearing a shirt. We can only presume what else he was not wearing. With women on board, however, some of the male astronauts expressed concern that sleep periods needed to be handled with more respect and decorum. Robert Overmyer, who was NASA's deputy manager for the construction of the space shuttle and the pilot on STS-5, which was 2 flights before Sally Ride, America's first female shuttle astronauts flew, noted that the practice before had always been that male astronauts slept anywhere and would often just sleep in their underwear. Overmyer felt that with these new mixed crews, there needed to be some policy on sleepwear that needed to be mandated. And in fact, there was. With the rise of the shuttle program, I mean, you see Anna Fisher in what is a flight suit, but the NASA human factors engineers started issuing a t-shirt and shorts and then slipper socks, essentially for sleepwear. As for sleeping anywhere, that still happens. But that said, I mean, this can happen in the space shuttle, but aboard ISS, engineers would actually reintroduce, oops, no, we don't want to go to that yet. They wanted to reintroduce the individual sleep bunks that they had on Skylab. Because the missions on Skylab and ISS were significantly longer than any shuttle mission, this pressing habitability issue regarding privacy and personal space dominated these designs. By far, and now we get to get over this slide, by far the most challenging habitability issue facing the astronauts and engineers was human waste collection. It is the question that every child will ask and every adult wants to ask: how do you go to the bathroom in space? Throughout the 1960s and into the 1970s, astronauts largely made do using urine and fecal collection bags. But with Skylab, the new focus on habitability and normalizing daily life for the astronauts, engineers designed a new facility. This is actually one of the space toilets from the shuttle, but the ones from ISS as well as the one on ISS and Skylab are very similar. The challenges to building a space toilet are many. I'll focus on a couple. The first one is, how do you simulate gravity? Gravity plays a major role in how a toilet works in space, or on Earth. In space, simulating gravity is actually the easy part, simply involving a fan to draw air down through the commode and creating a suction effect. Sally Ride has described the experience of using the shuttle toilet as being very similar to sitting on a vacuum cleaner. A second major challenge involves how you handle human waste once it leaves the body. First and foremost, some of these waste products need to be collected for medical data. And if you actually look at this toilet, what you see is there is this hose. So you attach a funnel to the hose, and then you can simply collect urine that way. Any other fecal matter that you would collect for medical experiments, you still would probably use a fecal bag. Everything else ends up going there. And I have to just include this. Any feces that's actually drawn into a separate container is chopped up into smaller pieces by a swirling device commonly known as the slinger, so that the water can actually be removed from all of these, from urine and fecal matter that's not saved for medical experiments, in part because human waste is actually very heavy. Generally, space toilets work well, but astronauts admit that it takes a little practice getting used to. When it does work, the toilet functions just as it does on Earth, but provides more privacy than the collection bags used during Mercury, Gemini, and Apollo. I think I'm actually going to skip some of the issues for women, which means I have to skip the diapers. I am so sorry about that. I'll show you quickly. To accommodate women for launch and landing, NASA came up with a couple of different designs. This I call the Chastity Belt design, that turns out to be pretty horrific. I have 1 minute to show you these. This is actually a design I found in the JSC archives, which the female astronauts did try out. Ray Seddon said she would take these home and try them out in the bathtub just to make sure they worked. At the same time that NASA is developing these devices, diaper technology comes into play. And this ultimately ends up being the solution for women astronauts during launch and landing, is to develop an individual diaper. This is Sally Ride's diaper, and it is part of the collection here. Now that adult diaper technology is readily available, it turns out that both men would prefer to use this than the traditional sheath design. I'll just leave it at that. In the 1990s, Johnson Space Center human factors engineers compiled a handbook called the NASA Standard 3000, which included the guiding principles for habitability in the human spaceflight program. Although compiled in the 1990s, clearly NASA had been using the organizing concept of habitability for 2 decades at that point. Now, 40 years later, Now, 40 years later, habitability remains a guiding premise behind current and future human spaceflight initiatives. Why? Well, from a historical perspective, we could argue that NASA's focus has changed since the days of the space race, as NASA's mission evolved from a political fight with the Soviet Union for global prestige into a more scientific mission of exploration. So too has our iconic image of the astronaut. Today, our astronauts are no longer cold warriors, but scientists and engineers working in a day-to-day laboratory. One last image. On September 1st, 2010, former Apollo 11 astronaut Buzz Aldrin, seen on the right, served as a celebrity judge on the space food episode of Bravo Channel's Top Chef. The challenge given to the chefs was to develop a meal for the astronauts aboard the International Space Station. The food had to meet the dietary requirements as well as the preparation and storage requirements for space food. And most importantly, it had to taste amazing. Barbecue short ribs won out and is now available on ISS. But this wasn't just another publicity stunt for NASA or for Buzz on that point. Rather, this interesting intersection of NASA design meets popular culture is a reflection of the agency's changing understanding about the future of human spaceflight. In order to extend the human presence in space, we need to validate traditions, routine, and stability for our astronauts, all factors that have become an important part of NASA's habitability dialogue as part of the process of innovation in the last 4 decades. And as a closing note, I will tell you that the astronauts and cosmonauts on ISS next Thursday will be enjoying the traditional Thanksgiving dinner, albeit it will be irradiated and thermostabilized. Thank you.